Hey everyone, so this is our next section in chapter 4. So this section is all about systems of linear inequalities. So before we've been talking about systems of linear equations. So we know equations have an equal sign, and inequalities, that's when we're dealing with less than, greater than, or less than or equal to, and greater than or equal to. So we're still talking about systems, which is like two or three or four different equations or inequalities you can see in this example here. Remember, this is a system. There's two inequalities going on there. And we're going to practice solving them. So let's take down some notes. System of linear inequalities. Two or more linear inequalities containing the same variables. Note, most systems of linear inequalities will have an infinite number of solutions. Okay, so we're going to think about that in terms of if I graphed an inequality, and if you remember, when we graphed inequalities, we used either dotted or dashed or dotted or solid lines. And so if I had this was a line and it was an inequality, we would shade, right? We would either shade above or below the line that we graphed. And then I could say, if I graphed another line, let's say this was the graph of it. And when I shaded, the only solution is where the two shaded regions overlap. So in this situation, in this example, this is where my solution would be, in this region of this graph. And that's why it's an infinite number of solutions. We're no longer looking at a system where the solution's the intersection, because with an inequality, it's all of these possible ordered pairs. So that's a big important thing. Let's continue here. The infinitely many solutions of a system of linear inequalities are represented by an overlapping shaded area, exactly like what I just said in the example above. And here's a little refresher. Remember, when graphing inequalities, the symbols less than and greater than are represented by dashed lines, and the symbols less than or equal to and greater than or equal to are represented by solid lines. So we really have to remember that when we graph. All inequalities are shaded above the line for when it's greater than or equal to. They're shaded below the lines for less than or equal to. And guys, that kind of makes sense, right? Greater than we shade above, less than we shade below. One solution is an ordered pair that makes a true statement when substituted into both inequalities. So a lot of times we're going to just, a question would say, okay, give me one solution to this system of linear inequalities. And that solution would be in the shaded region. And you can pick any point in the shaded region. That point would be true in both solutions. And that's what this first example is about. It says, determine if the ordered pairs below are solutions to the system of inequality below. So what we have to do to determine this, we have to substitute to check. Okay, so if you think about this, guys, it says, is 3, 5 a solution? Remember, 3 is an x value, 5 is a y value. And what we're going to do is just substitute into both parts of this system. So what I can set this up as y is less than 2x, and then the other one is y is greater than or equal to x plus 1. And I'm going to just substitute my x and my y into both of these inequalities. So it's y, which is 5, is less than 2 times my x, which is 3. When we simplify this, so I'm going to have 5 is less than 6. And I want to check this. Is this true? Well, that's true. So far we're good. And we need to have true inequalities for both of these systems here. So I've got now y, which is 5, has to be greater than or equal to x, which is 3, plus 1. And I've got 5 is greater than or equal to 3 plus 1 is 4. Okay, well, that's true again. So we can say yes, if they're both true. So now let's check this next one. We've got -2, 0. And again, I've got my x, comma, my y. And we're going to substitute it into both of these inequalities in the system. Y is less than 2x, we're going to check it, and y is greater than or equal to x plus 1. So I'm going to go y, which is 0, is less than 2 times my x, which is -2. 0 is less than 2 times -2, well, that's -4. Is 0 less than -4? No, that is false. So we can just say no, it's not a system right away. Okay, so that's how we check. This is what we got to remember, substitute to check. Now we're going to practice finding the systems of the solution of it, find the solutions of the system of inequalities below. So we need to do some graphing. If we look at A, we've got our system here. And remember when we graph lines, because these are both lines, we first graph the y-intercept, and then the next we use the slope. Okay, so what's my y-intercept of this first inequality is 3, so I put a point on 3, and then my slope is a -1, so I'm going to go up 1 and to the left 1 because we've got a negative slope goes to the left. And I'm going to plot my points. Whoops. Down 1 over 1, down 1 over 1, down 1 over 1. And I want to check out my dotted line or solid line. I know it's going to be a dotted because it's just less than. So I'm going to dot this as best as I can. Okay, and then my other line we've got to have in here, the y-intercept is 0, right? Because that's going to be plus 0. And then my slope is 2. So I'm going to rise 2, run 1, rise 2, run 1, rise 2, run 1. Okay, and I'm going to go all the way through here. And it's going to be solid because it's a greater than or equal to. Okay, now we have to do some shading. And really, I probably should have shaded this a little bit earlier before I did the second line. But so for the one that's light blue, let's go back to this light blue one. Y is less than, so if it's less than, we shade below. So I find this blue line and I'm going to shade below it. And then we're going to do our purple one. It's y is greater than, if it's greater than, we're going to shade above. So I find the purple line and above it is over here. So then my solution is everything that's shaded twice, right? So when we look at the shaded region, we are looking at right here. Because notice this region is shaded twice. So the question that we're going to see a lot is, what is one ordered pair that is a solution? We can pick any point that's in this yellow region. Doesn't matter. I could just pick anyone. I go -3, 2. We can have any of these points. If you want to pick this one, all of us could have different answers as long as we're in that yellow region. Okay, let's check out B here. Let's do some graphing. Y is less than 3, so my y-intercept, that's 3. There's no slope, so we know it's a horizontal line. And it's a less than or equal to, so it's going to be solid at 3. Let's do some shading here. It's less than, so we're going to shade below. And I'm going to go like this. Below is my shaded. Now let's check out our other line. I've got y is greater than x plus 2. 2 is my y-intercept. And my slope is 1. So I'm going to go up 1 over 1, up 1 over 1. Rise 1, run 1. And I'm going to go like this all the way through. And we've got a less than, so that's going to be dotted. Best as I can dot this line. And then I have to do some shading. So it's greater than, so I'm going to shade above. And then you can see which region of this graph is shaded twice, right in here. And then my question, we have to go back to what is one ordered pair that is a solution. I just pick any point that's in that yellow region. I'm going to pick this one right here. So I've got -8, 2. Guys, you can have any point listed for that answer. We can have many different answers as long as it's in that yellow region. Okay, let's check out problem 3 here. The graphs of y is less than -x minus 1 and y is less than or equal to 2x minus 3 are shown below. 4 regions are formed by the graph, and you can kind of see the 4 different regions. And we're going to answer these questions. Which region represents coordinates that satisfy neither inequality? So we've got A, B, C, and D. Which region doesn't have a solution to either line that's drawn? And so we'd have to say A, there's no shading here. So there isn't any solutions because there's no shading. B, which region represents coordinates that satisfy both inequalities? So which region, A, B, C, or D, has the most shading? That's region C, double shading. Means it satisfies both inequalities. Which region represents coordinates that satisfy y is less than -x minus 1, but not y is less than or equal to 2x minus 3. So we've got to figure out which line is this. Y is less than -x minus 1. I use my y-intercept always is -1. So this is our line, this dotted one. And it says is less than. So less than is region is over here. So that's going to be region D. It's not C because it says but not the other one. C would be the other region. Which region represents coordinates that satisfy 2x minus 3? Well, that's going to be our other line here. And it says less than, so we'd shade below, and it would just be region B. Okay, and then let's check out problem 4 here. It says write the system of linear inequalities shown in the pictures below. So we've got to write our lines. So again, when we write lines, remember, and inequalities, we have, I'll just say less than mx plus b. So we start with the b and use the slope. So I'm going to start this y. Let's just do the top one. Let's say this is 1. I look at my y-intercept. What's my y-intercept? That's going to be a 3. Let's look at our shading. So first I know it's a dotted line, so it's not going to be or equal to. I do know we shaded above. So if we're shading above, I know I need a greater than. Is there any slope here? No, right? There is no slope. So I just know my equation is y is greater than 3. Let's check out the other one, inequality 2. I've got y, let's see, I shaded below, which means less than, and there is a solid line, so it's got to be or equal to. My y-intercept is -1, and there's no slope. Okay, let's check out over here. You got inequality for B. Inequality 1, let's just say, is this one. I'm going to start y. Let's see, I shaded below, so it's going to be less than. It is a dotted line, so it's just less than, not or equal to. And then I start with my y-intercept. My y-intercept is 1, and my slope is rise 1. And then how much do I have to run? Let's say right here. So I'm going to, I think this is rise 2 actually. Yeah, rise 2, and then run 1, 2, 3, 4, 5. X plus 1. So remember our slope is rise over run. And now let's check out the other inequality. So I've got inequality 2. Let's go y, and then I look for, am I shaded, this line right here, did we shade above or below? And it went above, so I'm going to go greater than. It's solid or equal to. My y-intercept is right here at 4. And we can check our slope. If I find, I just drew all over it, but let's clear this off. If I find a point Let's go with this guy and this guy. I can do my rise is 1, 2, 3, and my run is 1. It goes in the negative direction, so I've got a negative slope. Okay, guys, that's a review of writing linear equations, which we did earlier this year. We see it again when we're talking about systems right now. Okay, great work, guys. Good luck completing the rest of the work.